Batteries are an area of mystery and confusion, so let's take a really good in-depth look at them and really learn everything we need to know about them. With solar power systems, the kind of battery we're going to be using is called a deep cycle battery, and it comes primarily in two types. Those two types we're interested in are the flooded electrolyte, which is a traditional wet cell battery, or the absorbed glass mat battery, which has a gelled electrolyte and is sometimes called a sealed cell. What this means is that a deep cycle battery is designed to be able to be discharged down to about 20% of its full capacity without any damage. If we compare this with a car starter battery, that's really just designed to give short bursts of high current to start a motor. They may look the same in construction, but you absolutely cannot use them in solar power systems. Deep cycle wet electrolyte cells are our #1 choice in battery backed up solar power systems. They're a proven technology, they're a little bit less expensive, and they're easy to operate and maintain. AGM cells are about twice as expensive and are excellent performers, but why would you choose one of these types? Well, you would pick them for these 4 reasons. If they were in a remote location, a place that you couldn't get to service them often, because these are low maintenance batteries. Or if there's vibration, say they're in an electric vehicle and there's potential for spilling the electrolyte. Well, these are gelled, they won't spill. Or if you need to mount them sideways, for some reason exactly where you have to put them, they can't be standing straight up. Well, these won't spill. And lastly, if you have poor ventilation, you need ventilation, but if the ventilation isn't quite up to snuff, you might choose an AGM battery. Several decades ago, nickel-cadmium wet cells were in common use in solar systems, but their liquid electrolyte is very caustic, and they've fallen out of favor. When we're considering deep cycle lead-acid batteries for solar power battery systems, we have 4 types that we're looking at. The first is marine deep cycle batteries, commonly called trolling batteries, and these are the least expensive batteries we can use and might last you up to 6 years. The second are golf cart batteries, and these come in many different grades and costs. The cheaper ones might only last a couple of years, and the better ones can last 7 years or a little bit more. Then we have our AGM deep cycle absorbed glass mat, as we spoke about. These are a little bit more expensive, but are very much specialty batteries, can last you 4 to 7 years in typical use. And then we have the industrial deep cycle battery. These are commonly used in forklifts and heavy equipment and are the most popular types for solar power systems. You can possibly get 10 to 20 years out of these batteries, especially the more expensive ones. The things that determine the quality of a battery are the thickness of its plates, actually how much lead is there, and how much electrolyte is around those plates. These are going to really determine the length that this battery will last. With automotive batteries, you're used to seeing a rating called cold cranking amps. You will never use this rating because you will never use a battery that has this type of rating on it. It's meaningless to us in solar battery backed up systems. What's important to us is the amp hour rating, the AH rating, as you can see on this battery. Amp hours is the amount of current in amps times the number of hours it can deliver that current. A 100 amp hour battery can deliver 10 amps for 10 hours, because 10 times 10 is 100, or 20 amps for 5 hours, because 20 times 5 is also 100. All batteries degrade in their amp hour capacity if too much current is drawn all at once. The better the battery, the more current that can be drawn without it degrading its amp hour rating. Typically, the amp hour capacity is diminished significantly once you are drawing more than about 30% of the total amp hour rating. This is why your battery bank has to be sized correctly for your system's delivered power. If you consistently draw more than the battery can safely deliver, you will decrease their useful life. Deep cycle batteries are typically rated at 2 different levels of power output. They do this by giving a time of usage until discharged. This is typically a 5-hour rating and a 20-hour rating. You'll see that if you discharge the battery in only 5 hours, the battery's amp hour rating is degraded. It actually has less capacity if you draw the power out too fast. And you should also be aware of battery group size. When you get an automotive battery, for example, it might be a group 27 or group 31. This designates the actual size and capacity of the battery. Well, here's the chart that shows you the group numbers and the capacity range in those groups. You don't need to know group size to specify a battery, but you do need to know that they relate to the size of the batteries. It's important to understand that battery capacity increases and decreases with temperature. The stated specifications will correspond to a temperature of about 77 degrees, but as you increase temperature, the chemical reaction inside the battery speeds up, and at colder temperatures, it slows down. This is why more people need jump starts in the winter. At freezing temperatures, you're going to lose at least 20% of your battery's ability to deliver power. So it's important to have enough battery capacity overall so that it can still function in colder temperatures. Know that the batteries are not damaged at lower and higher temperatures, but the chemical reaction speed is changed and the battery's capacity is reduced about 20% at freezing and increased about 10% at 120 degrees F. How many times can a deep cycle lead-acid battery be charged? Well, a quality deep cycle lead-acid battery will be able to be charged fully and discharged by 80% down to 20% of its capacity up to about 1,000 times. Now, if you're discharging less than 80% down, it'll give you more daily cycles because you're not going through a full discharge cycle all the way from the top to the bottom. That said, batteries need to be exercised. If you don't routinely discharge a battery by at least 5%, it's going to be damaged by the buildup of lead dioxide on the plates. As well, batteries also lose a little power daily by a process called self-discharge. Lead-acid batteries lose a little bit more than AGM. They lose a little bit less through self-discharge. How do we tell how much of a charge we've got in a lead-acid battery? Well, there are several techniques which we will show you, but one way to determine the battery's state of charge is by testing its voltage. In other words, the degree to which a lead-acid battery is charged is reflected in its voltage. Here's a little chart with what I call the voltage landmarks. If you memorize these 4 voltage points, you will be able to tell at a quick glance how much of a charge you have left. You would be looking at this voltage when the batteries are at rest, not when they're being charged, and not when they're under a full load, actually supplying power to your appliances. You can just double these if you're running a 24-volt battery bank, or multiply by 4 for a 48. You'll notice on this display that the battery voltage is higher than 12.7 because during the day, the system raises the voltage up to force power into the batteries. Well, we've learned a lot so far. Let's do a quick review. Deep cycle batteries come in flooded, wet cells, or AGM, absorbed glass mat sealed gel styles. A deep cycle battery can be discharged down to 20% without damage. You must use golf cart, marine deep cycle, or industrial batteries in solar power systems. A battery's quality is related to its lead plate thickness and how they're constructed. Amp hours are the real way to determine the capacity of a battery. Batteries prefer a temperature of about 77 degrees. Performance is going to vary with temperature. The state of charge of a battery is directly related to the battery's voltage. Batteries must be exercised or they will be damaged. And batteries self-discharge over time. In your system, the charge controller is going to charge the batteries using 3 different phases of charging. The first is called a bulk charging phase, and this charges at the maximum safe rate until the battery's about 80 to 90% charged. The second is the absorption charge phase. This holds the voltage constant until the battery is fully charged. And the last is the float charge phase. Once it's fully charged, a very low charge rate keeps the battery full without overgassing it or overcharging it. This will all be done automatically without your assistance by the charge controller and is the optimum way to charge lead-acid batteries. Here's something to know. Unlike some rechargeable batteries, lead-acid cells do not have a memory. You do not have to cycle them fully to keep their capacity up. That said, they do need about 30 charge cycles when they're new to reach the full capacity. Now I'm going to talk about how to check a battery's state of charge using a hygrometer. And we're going to use this solar charged electric vehicle's batteries to show you how to do it. Remember, safety first. Wear your safety goggles, and if you want, some latex covering gloves if you're sensitive to sulfuric acid. Remember also that sulfuric acid melts cotton clothing, so don't wear anything you don't want to put holes in. So let's get started. Now we're going to check the state of charge in these liquid-filled batteries by using the hygrometer and actually dipping it into each one of the cells, sucking up the acid, and then looking at the chart on the side of the hygrometer to see how much charge is in the electrolyte. So we first remove the caps. However, if they unscrew them. If they pull out, or like these have 3-in-1, pull them all out at the same time. Be very careful. Take the clean end of the hygrometer and put it into the cell all the way, and then squeeze on the hygrometer bulb so that it sucks up the acid fully into the hygrometer itself. And then you can check the reading. Sometimes you've got to tap it a little bit so you can see what the needle's showing. Our meter's showing a 1.3 here, which is all the way at the top of the specific gravity of the electrolyte in the battery. That shows us we have an absolutely full charge in this battery. Your hygrometer may be the bulb type with the floating balls, each corresponding to 25% of a charge, 25, 50, 75, and 100. Now remember that there can be dried sulfuric acid on the top of the battery or the hygrometer or anything you're touching in this area, so it's really a good idea to go ahead and wash your hands fully after you've serviced the batteries. It has a sort of almost sticky or a dry feeling on your fingers. You'll know you've got a little bit of battery acid on there, so a thorough washing is definitely the thing to do. A battery hit point, the level of the electrolyte will vary up and down depending on how much the battery is charged. So remember to check and fill your batteries when they're full or nearly fully charged. I wanted to add a few simple rules that you need to know. Never mix batteries of different ages, even if they're the same type, or types in the same battery bank. They need to be all the same age and the same type. Use only distilled water to refill your batteries. Never add acid, just use distilled water. Always ventilate the battery box to get the gases out which are produced during charging and discharging. Keep the battery caps on while charging because the electrolyte's going to bubble with gases and some battery acid could get out of the top if the caps are not on. And lastly, only look at the battery voltage to determine the state of charge at least an hour after it's been charging, because the voltage will be temporarily elevated from the charging process and need to come down and stabilize to give you an accurate reading. Batteries most commonly fail from sulfation, which is the buildup of lead sulfate crystals on the plates. Now you can avoid premature battery failure by following good battery maintenance procedure as outlined in our video. So to keep your batteries healthy, you've got to be sure that you cycle them. Do not leave them sitting there discharged. At least a 5% discharge and bring them back up to dissolve everything back into the solution. The next thing is to keep them topped off with clean distilled water right to the point where I'm going to show you. And as well, keep the connectors clean. Use a little bit of baking soda and water and an old toothbrush and clean off anything you see on there in the way of buildup around those terminals regularly. As well, be sure that you use an equalizing charge, which normally your charge controller can handle automatically about once a month to keep the electrolyte mixed up and keep everything moving inside the batteries. I'm going to show you the exact way to fill up the electrolyte on your batteries. First thing to have is a funnel. This is a dedicated funnel that you will never use for anything else. It will never be used for food again. And then pure, clean distilled water. Don't use anything else. Never put battery acid into batteries, only put distilled water. Now remember not to have any open flame, no smoking around batteries, and of course wear your safety glasses. If you do not wear safety glasses, you are asking for trouble. Full coverage safety glasses. Then remove the caps of your batteries one at a time and check the electrolyte level. Go ahead and put your funnel in. Be sure there is no dirt getting into the opening whatsoever, and put small amounts of distilled water in and recheck the level. The capacity should be fairly large, so it's not that easy to overfill it. But the idea is to check it often and get it filled exactly correct. We're looking down into the opening of the battery, and we can see that the electrolyte is bubbling from the process of charging, and the gases are coming off. And we can also see two thickened areas at the top of the opening. These are the indicator bars that go down to show you the correct level. And the correct level to fill the battery to is above the plates. Never let any of the plates be exposed, but do not bring it up all the way till it touches the bottom of those thickened plastic bars that go down on the left and right of the hole. Don't come all the way up that high, and never fill it all the way to the top, because battery acid will come bubbling out onto the top of the battery. So always have the plates covered, About a 1/4 inch above the plates is good, 1/4 to 1/3 of an inch, but do not bring it up to the opening of the battery hole itself. Now remember that battery electrolyte is sulfuric acid. It's diluted, but it's still quite powerful. So it's very important to have a base on hand, some baking soda for emergency spills. As well, you can mix a little bit with water and have it in a jug, have a little concentration of a base, as we call it, baking soda, to neutralize acid should you spill some. Here's a great hit point. You can significantly reduce the need to water your batteries by purchasing recombiner battery cell caps. These actually recombine the exiting gases from the battery back into water and put it back into the battery. Let's do our final review in our overview of battery technology. Batteries can die from sulfation. That's that lead sulfate crystal buildup on the plates. A hygrometer tests a battery for its state of charge by showing us the specific gravity of the electrolyte. Batteries are charged with a 3-stage process, and this is automatically handled by your charge controller. Batteries produce explosive gases, and they do need ventilation. Lead-acid batteries have no memory effect. Use only distilled water when refilling a battery, and wear safety glasses and gloves when working. You can also have some of that baking soda around for acid spills.